Hey you guys. Today we're going to take a look at applications with trigonometry. We're still going to be using SOHCAHTOA, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we're still going to be using those, but now we're just going to kind of put it in a word format, it's going to give us a little scenario, but we're still going to be using that basic concept. So let's go through and talk about this concept of angle of elevation and angle of depression. An angle formed by a horizontal line and the line of sight to an object above the level of the horizontal. So I have this diagram here. This dot that I try to make really big on purpose is where you are. If you're looking up, the angle that's formed is called the angle of elevation. So that's where I highlighted here in this pink. So if this is you and you're looking up, that is an angle of elevation. Hopefully that makes sense. If you elevate something, it's going up. So an angle of elevation is going up. The horizontal that they mentioned in this picture is just this horizontal line. So this is your normal line of sight if you're just looking straight, looking horizontal. But when you look up, that's called the angle of elevation. Likewise, an angle of depression is an angle formed by a horizontal line in a line of sight to an object below the level of the horizontal. Again, this dot here that I try to make big is where you are. And if you're going to be looking down, that's an angle of depression. So that's this pink that's highlighted here. So looking down, depression, and this is normally where you're looking on the horizontal. You're going straight, going straight, going straight. But if you look down, it's the angle of depression. And if you look up, that's an angle of elevation. So we're going to use these two to help us solve some different problems. We're going to be finding the height of a building or finding the height of a tree and different things like that. So we're still going to be using SOHCAHTOA. So let's get started. All right, example 1. From a point on the ground 50 feet from the base of a tree, the angle of elevation to the top of the tree is 33 degrees. How tall is the tree? When you're doing these problems, it is a beautiful, great idea to draw a picture. Even if you're not the best drawer, it's still just a great, wonderful, beautiful, fantastic idea to draw a picture. So here I go. I'm going to draw a picture. All right. Let's see what I know. From a point on the ground, 50 feet from the base of a tree. So this is my tree. Okay, again, I'm not the best drawer. That's my tree. 50 feet is 50 feet out. Okay. And I know that's the base. It says up here in the base, so that's the bottom. The angle of elevation to the top of the tree is 33 degrees. So we're over here. This is 33 degrees. And that's all we need to know. And we're looking for how tall is the tree. Now, this is my drawing of the tree, but the tree is actually going to reach all the way up here. So we're trying to figure out what is the height of the tree. So we're down here on the ground and we're looking way up here trying to figure out how tall the tree is. Now, if you need to write this down again, so that we'll know what we have and what we're looking for. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So if I look over here, if I'm looking for x, it looks like, this is my angle of reference. It looks like I have an opposite side in x and I have an adjacent side. So we're going to be using tangent. So I'm using tangent because I have the opposite side. X is what I'm looking for, the height of the tree. And I know the adjacent side is 50. So I'm going to set up a tangent relationship. So the tangent of 33 is equal to x over 50. So tangent is equal to the opposite over the hypotenuse. So we solve for x. The opposite of dividing by 50 is to multiply both sides by 50. Now we're going to go to Desmos and type this in. And I feel like I've already typed it in. So let me pull up Desmos and see what we have here. Okay. So it's this first one here. So we're going to type in 50 tangent of 33. So we're on problem number 1. I know there's some other stuff in here that's coming up later, but we're on problem number 1. So 50 tangent of 33. I typed that in Desmos. Make sure the little toolbar over here where it says graph settings, where I'm circling around, make sure you are in degrees so that you can get the correct answer. So the correct answer to this is 32.5. We can round to the nearest tenth. So we'll take that and we will round to the nearest tenth. So the height of my tree is 32.5 feet. So that is our answer for the first one. Draw a picture. It's at elevation. That means I'm going up. So that's how I knew that my angle was here and I'm looking up. And yeah, so that is that one there. Number 2. Okay. Sam is standing 30 feet away from a building. His eyes are 6 feet above the ground. Sam spots Aaron on the 5th floor at a 58-degree angle of elevation. How high up the building is Aaron? So again, let's draw a picture. Sam is standing 30 feet away from the building. That's going to be your base. We're 30 feet away, so we're going to label this 30. What else do I know? His eyes are 6 feet above the ground, and Sam spots Aaron on the 5th floor at a 58-degree angle of elevation. So 58 is going to go here. So here we are, or here Sam is, rather. Sam is looking up. So that's how I knew to put this angle here. Sam is looking up at his friend, and he sees Aaron way up here somewhere. So we're down here on the ground. We're looking up. That's my angle of elevation where my pen is going at. We're looking up. And up here, I see that Aaron is up here. So, and we are looking for how high up the building is Aaron. So I'm looking for this here. So we set up a relationship. Hopefully you notice this is another tangent problem. I have the opposite side that I'm looking for, and I know my adjacent side. So this is the tangent of 58 degrees. Is equal to the opposite side, which we don't know, over the adjacent side. We multiply both sides by 30, and you get 30, 10, 58 degrees is equal to x. Now we go type this in Desmos. So we go type number 2 in Desmos, and I already have it typed in for us. Again, make sure you're in degrees, and we type in 30, 10, 58, and we got 48. So I got 48 for that problem right there. So my answer is 48. However, and I'm going to keep a few more decimal points, and we'll just round at the very end. However, it says his eyes are 6 feet above the ground. So this is where we are so far, but I need to add in the fact that we are 6 feet above the ground. So we add this together, and our final answer, and I am rounding, is going to be 54. So I'm rounding to the nearest 10th, but this 1 makes it stay 0. So I'm rounding to the nearest 10th just to stay consistent. I got 54 feet. So that is how high up the building Aaron is. Okay, we'll try 2 more. On number 3 down at the bottom there, a surveyor is 130 feet from a tower. The tower is 86 feet high. The surveyor's instrument is 5 feet above the ground. Find the angle of elevation from the instrument to the top of the tower. Again, a picture is going to be our best friend when we're doing these. And we know we're working with right triangles because SOHCAHTOA only works in right triangles. Okay. The surveyor is 130 feet from the tower. The tower is 86 feet high. So I'm labeling as I go. The surveyor's instrument is 5 feet above the ground. Find the angle of elevation from the instrument to the top of the tower. So this time I'm looking for an angle measure. So I'm looking for this angle of elevation here. I know I have my opposite side and I have my adjacent side, and we're looking for the angle of elevation. So I almost have everything I need, except for I do want to consider the fact that I'm 5 feet above the ground. Well, the instrument that this person is using is 5 feet above the ground. So I need to add 5 feet to this side. So that's simple mental math. So I add 5 and I got 91. So technically, my triangle looks more so like such. So technically, this is the triangle that I'm looking for, and I'm looking for x degrees because I had to add 5 over here. This is still going to be tangent, so there's a lot of tangents going on. I don't feel like you're doing anything wrong. I still have my opposite side, and I still have my adjacent side. So this is going to be the tangent of x is equal to my opposite side over my adjacent side. So the tangent of x is what we're looking for. We're looking for the angle measure is equal to the opposite side over the adjacent side. Now keep in mind, since I'm looking for an angle measure, I have to use my inverse. And this is what we type into Desmos. Since I'm looking for an angle measure, you have to use the tan to the -1. The -1 lets us know I'm looking for an angle measure. It's the inverse. So we're going to type in tan -1, 91 divided by 130. So the inverse of tangent. So I already have that typed in for us, but I want to make sure you know where your buttons and stuff are. So I typed in the inverse tangent of 91 divided by 130. Now, if you go down to the bottom, you'll see your Desmos keyboard to help you type this in. Here it is right here. If you go to functions, this is where you find your angle stuff in case you forgot. So I already typed it in, but this is your tangent button where my mouse is hovering around there, and you type in your number. The general rule of thumb is that if you're doing a side length, you're going to round to the nearest tenth or hundredth. And if it's an angle, you're going to round to the nearest whole number. So this is 34.999. So if I round to the nearest whole number, it's going to be 35 degrees. So the answer for this particular problem is 35 degrees. So 35 degrees. And let's take a look at one more word problem so we can draw a picture, set up our relationship, and then be able to solve the problem. So we're going to try one more word problem. And let me find one that is not tangent so you don't think that we're always going to do tangent. So I'm going to skip around a little bit. I'm going to go down here to this one about the ladder against the wall. Because the first ones that we've done, they were all tangent, but I don't want you to think that everything's going to be tangent. So example 6. So I did skip. I'm on example 6. A ladder is leaning against a wall. The ladder makes a 35-degree angle with the wall. If the base of the ladder is 8 feet from the wall, how long is the ladder? So let's draw our picture and fill in what we know based off of the problem. So this is going to be my ladder. The ladder is leaning against the wall. So the straight line is the wall, and this is my ladder leaning. The ladder makes a 35-degree angle with the wall. So that has to be this angle up here. Because this is the ladder that's leaning, and then this is the wall. So this is the angle that's formed. That's 35 degrees. If the base of the ladder is 8 feet from the wall, so this is the base, it is 8 feet from the wall. How long is the ladder? So we're looking for this length right here because this length is our ladder. So that's going to be x. So this is not a tangent problem. So if I'm looking for x, let's label some different things that I know. I know that this is my angle of reference. It's 35 degrees. If I go opposite of that, that's 8. That's my opposite side. I found my right angle, go directly across from that. That's my hypotenuse. So which one of our trig functions deal with opposite and hypotenuse? This is going to be a sine problem because sine is opposite over hypotenuse. So this is sine opposite hypotenuse. So the sine of 35 is equal to my opposite side, which is 8, over my hypotenuse, which is what we're looking for. I need to go through and solve this problem. The opposite of dividing by x is to multiply both sides by x. So this is going to be x sine 35 is equal to 8. The opposite of multiplying by the sine of 35 is to divide both sides by the sine of 35. And then we'll do our thing. We type this in Desmos, which I've already done. And to be consistent, I think I was doing the 10th on the front page. So this is going to actually round to 14.0 if I round to the nearest 10th. And this is feet, I believe. Well, yes, it's feet. So I had to go through and read the problem there. So this is feet because I got 8 feet up there. So take home point. Draw a picture, draw a picture, draw a picture. Figure out what you know. In this particular problem, I knew the opposite side and the hypotenuse. On the first 3 problems, I knew the opposite side, I knew the adjacent side. So figure out what you know, and that'll help you set up your relationship so you can find the height of a tree or a missing angle as you go through and do your word problems.